Hello everyone. Today I'm here to present my final project 5550. Mm, My name is Pedreddy Amita Reddy. Here is my student ID 1164534. The part one. Coming to the part one, use TensorFlow directly in coding. So there were few questions given. The first question, is the student required to use the TensorFlow directly in coding, whether it might be build, train, and testing the CNN model for this assignment? The answer is yes, absolutely. I use the TensorFlow directly to code the build and training and testing the CNN model for this assignment. So, student can also work with the neural networks and machine learning models using TensorFlow, a preferred and effective deep learning framework. When using TensorFlow effectively requires, then you must normally use its basics APIs to create neural network designs, specifying a training cycle and carry out all other essential actions for the CNN model. So, and the next question is, should the student use Keras in coding to build the train and test the CNN model? Actually, we didn't use, particularly in this homework, the student is not used like Keras in coding to build, train, and test a conventional neural network. And a high-level deep learning library called Keras makes it easier to create and train neural networks. However, coming to this assignment, I didn't use a Keras in coding, and they might, and students may need to use more simple deep learning frameworks such as TensorFlow because of the absence of Keras. So one must construct CNN using a different methodology or frameworks. So coming to the part two. Mm, Part two, the dataset I have chosen is a cats versus dogs dataset. So the reason why I have chosen this data set is because earlier it was popular data set used for image classification tasks, specifically designed distinguish between the images of cats and dogs with respect to the labels given in the images. Here are the details in the data dictionary for the cats versus dogs dataset. Coming to the data description, the cats versus dog dataset is specially used to train and test the machine learning models to tell if an image contains a cat or a dog, and actually, it has a lot of cats and dog pictures, making it great for training image recognition system. And also, the dataset includes of different breeds, like almost 500 breeds. So it's good for fine tuning models to recognize specific types of cats and dogs. It's important for computer vision research because it provides a standard set of images for developing accurate model that can classify photos as either cats or dogs. So in the data dictionary, image a TensorFlow containing the image data and the label binary classification between the distinguish between the cats or dogs, whether so it was indicated with the C or the dogs as a D with the image size. Attributes. The dataset includes both the images, labels, as I already told you, cats or dogs, allowing the binary classification task easily. Each image is associated with a specific label indicating the animal in the picture, and training and test datasets. Test sets. So the dataset is divided into separate records for training and testing. A lot of training set is the size I mentioned here, and for the testing set is 12,500 images approximately, and few of the applications that I also mentioned here. For the image classification, classifying images as either cats or dogs, it is used for the image classification purposes, and the deep learning model, training model for image recognition task. Here is a link that I found the data set and also the code. And if you need, you can also download this from the Microsoft website. Coming to the part three, the obtained CIFR 10 data set. So for this part three, the process that was like done in the Canvas, the dataset is available in the Canvas module. Um, Actually, it and then transfers those files to remote virtual machine that is stored on a Google Cloud platform. Multiple stages were necessary to complete these duties, but they were all effectively carried out in accordance with the guidelines provided by the professor in the Canvas. Um, so downloading of the dataset is like few steps. First step of the process, where I have opened the Canvas model, going to the designated flow folder, and I have downloaded the everyone of the 7 dataset files linked to the CIFR 10 datasets were the first steps in the procedure. In order to complete the downloaded following these steps, I've successfully signed into the Canvas and found the necessary module and did everything uh, as required, as suggested by the professor. And the next step is the transferring data file to the remote virtual machine. In this, I have opened the new terminal in my computer in which I have downloaded the software. I uploaded the downloaded dataset files to the remote virtual machine using the SCP commands. The SSH command, sorry, accessing the remote, here comes accessing the remote virtual machine in GCP using SSH commands. As I already told, the computer is opened in which the SSH software were installed. The following commands generated as, I can show you the commands that were used. The basic commands to start with the, it's just a gcloud SSH with the name and the virtual machine followed by the using all these commands I can connect to the virtual machine in GCP with the SSH. A subfolder, a CD indicates to open the data file, and in the data file we have the all these 7 data files have been uploaded in it. Here you can see the picture of it. Coming to the part 4, build, train, and test CNN on our CFR10 dataset. So let's begin. Starts with the architecture of the CNN model. Okay, actually, this CNN model, it has 3 layers, namely convolutional, pooling, and a fully connected layer. It is a class of neural networks and a process data having grid layer topology. The convolutional layer is the building block of CNN, carrying with the main responsibilities for computation. Pooling reduces the spatial size of the representation and lessens the number of computations required. Whereas the fully connected layer is connected to both the layers and the recent one. So coming to the coding part of the part 4. Here the libraries has been imported for the coding, and everything in the dataset has been uploaded and loaded, as you can see. So coming to the display several examples of single image. Here what exactly is done is that this code loads an image dataset and displays the first image using a matplotlib. The first reshapes the image data to the right format for matplot, then it normalizes the image data, so the pixels value ranges from 0 to 1. Finally, it uses matplotlib and shows functions to display the image. Here are the images. And few of the supporting functions to rearrange data. Um, um, in this code, it defines the functions to create different layers in a convolutional neural network in the CNN model. First one, few of the functions that I'll tell you what exactly does this functions use. The initialization weight function. This function initializes the weight of a convolutional filter randomly using a normal distribution. And the initialize bias function. Initialize bias function. This function initializes the bias of a layer with a constant values. And the create convolutional layer and a compute dot. Can show you the point where exactly it is. And the function that I talked about is initialization weights and the initialize bias. And this function create convolutional layer and compute dot product. This function creates a convolutional layer in the network and computes a dot product between the input and the filter weights. And the create ReLU layer and the compute dot product plus B function, it creates the rectified linear unit layer in the network, which applies the activation function to the output of a conventional layer and adds the bias. In the create max pool and reduce spatial size, this function, it creates a max pooling layer in the network, which reduces the spatial size of the input data by taking the maximum value within a 2x2 window. And this function, the last function, it also creates a fully connected layer in the network and computes a dot product between the inputs and the weights, then adds the bias. So all these functions perform a specific operation in building a CNN model, like initializing weights and biases, performing convolutional, applying activation function, and pooling, etc. These functions helps in creating the layers of the CNN model. So coming to the phase one, phase one of build convolutional neural network. So in this part, building the CNN model, first we'll provide a placeholder value X as input, then we'll give the input shape as 3 to 3 32 32 a none, and to retain the input picture data, this placeholder is made. A configuration number of images has been taken, each with a dimension of 32 32 pixels, and triple color pathways can be accepted by the shape none, 32 32 and 33. So next, we'll use the convolutional layer. In the convolutional layer, I'll give the input values for filter shape as 5 5 3 32 in the filter shape, and giving padding values as same for ReLU. Activation and 32 filters of 5 5 square are applied to the picture input by the first convolutional layer. It makes use of ReLU activation and the same padding, meaning that the output has identical length and width as the input. So coming to the next layer is pooling layer. In this pooling layer, in this max pooling using 2x2 filters and stride in order to decrease the geographical size of the data, maximizing pooling with the 2x2 filters, choose the highest value in each 2x2 zone. So this layer that we will use is the convolutional layer 2. In this convolution 2, we'll give the input for filter size shape as 5532. 333264, and gave the value of ReLU padding as same activation. Then we'll use a pooling layer 2. In the pooling layer 2, the max pooling is 2x2 kernel and straddle. It indicates the pooling layer. I reduce the number of dimensions by max pooling, the result convolutional layer 2. Later, the flattering layer will be used in order to make it ready for the layer it completely. So the flatten into a vector in one dimension with the dimensions of -1, 18 to 18 to 64. Here you can see. Next, fully connected layer. In this layer, we'll provide the size of the output layer as 1024. Output size is given, and the ReLU activation with 1024 neurons. You can see the result and function that fully linked layer process inputs. Then we'll use some dropout layers. Next, in the dropout layer, we'll give the input size. Input size with the 0.5 for keep probability, the addition of layer for dropouts that includes 50% of the neurons during training. Then the next one is finally fully connected layer. In this, we'll provide 10 output size by assuming the work involves a 10 classes analysis, using a rate of learning 0.001, and the Adam optimizer is above list. So coming to the phase 2, the train test and CNN model on CIFR 10 dataset. Using the CIFR 10 dataset to train and test the CNN model, firstly, initializing the variables. The initialization of the global variables prepares the system for training. The training cycles will give the input step as 5000, which indicates the 5001. It means that the 5000 steps training loops updates the neural network parameters and weight using the CNN trainer. Using small batches of data used for training batch X to batch Y, the testing accuracy for every 100 steps throughout the training. The system accuracy is assessed by contrasting the two labels. So the overall the accuracy that the result we got is like 5,000 steps. It was like 65%. The CFR. So after complete successfully running the code, the final test accuracy of the presented CNN model is 65%. This indicates that evaluated on the CFR10 dataset, it accurately identified the categories for about 65% of the pictures. So giving the extensive nature of the dataset that includes 10 distinct categories. This shows that the system does moderately well in image categorization. The model accuracy was 65%. It means that it suggests that it correctly predicts approximately two-thirds of the test photo. There is still potential for enhancement, even though this efficiency can be satisfaction for some applications, such as higher accuracy on this project might be achieved by further modification of the model parameters, altering parameter values, or investigating more sophisticated designs. To decide whether this degree of precision is adequate or if additional optimization is required, it is critical to analyze the particular applications and area requirement. So what I can conclude is that the CNN architecture and training methodology have been clearly laid out. The testing steps evaluates the model's capability to categorized. And here I can show you the picture of this and also the conclusion that I made in as the testing steps evaluates the model capability to categorize photos into one of the 10 predefined groups. The model is configured to deal with image data to access the model efficiency in real-world classification of image tasks. More evaluation of its effectiveness, particularly training and validation accuracy, would be required. Coming to the part 5, so the first question in the part 5 is the dataset of accuracy level produced by the CNN with the MNIST dataset that the student worked on in homework. For the MNIST dataset, the CNN model achieved a high testing accuracy for around 98.77%. This indicates it's very good at recognizing hard-written digits. The model uses a well-organized architecture with two conventional layer, max pooling, and a dropout layer to prevent overfitting. On the other hand, and the second question is the dataset of accuracy level produced by the CNN with the CIFR10 dataset. So in contrast, the second data set employs the same CNN with the CIFR10 dataset. The CNN model reached a testing accuracy of about 67.44%. This means it correctly identified categories for about two-thirds of the images. The CIFR10 dataset is more complex with colored images into categories, while 65% accuracy is acceptable. There's still room for improvement possibility by adjusting the parameters or exploring complex designs. So coming to the third question, the result of comparing these two data sets. Result of comparing these two data sets. Comparing these two data sets highlights specifically the difference in the complexity and their impact on CNN performance. The MNIST simplicity facilitates higher accuracy, whereas CFR10 complexity presents the challenges. This performance gap stems from factors such as dataset complexity, model architecture, suitability, hyperparameters, and optimization, training dataset size, and potential overfitting. Coming to the fourth question, the explanation of the gap in the performance of these two CNNs used on these two datasets. If such a gap exists, actually, it has a gap. The performance gap between the two CNNs can be attributed to several factors. Firstly, the complexity of the dataset plays a role. CFR10 colored images make it more challenging. The minced grayscale digits. Additionally, the model architecture might not be optimized for both datasets. and different hyperparameters may be needed for training. The size of the training dataset also influences accuracy, with CIFR-10's large and more diverse dataset potentially affecting performance. So finally, overfitting to the MNIST dataset could hinder the CNN performance on CIFR-10. So, in summary, like what we can conclude is difference in dataset complexity, model architecture, hyperparameter overfitting contributes to the performance gap between the two CNNs. Adjusting all these factors can help improve accuracy on each dataset. Part 6. In part 6, we have done the improvised version, improvised convolutional neural network performance. So, what are the changes that we made in this? Or I can show you. This is the code of the, as usual, we are imported all the libraries, and the data file has been uploaded and loaded. Everything has been done, the images, the supporting functions. Here's a improvised version. What we made is that these changes that I have made to improve the CNN performance is like in this, I have expanded the convolutional neural network design by including a third convolutional layer in the given code. So this is the part where we did, and third convolutional layer is a new layer that comes after the ReLU activation and before the polling layer. The goal of adding this layer is to make the network deeper and more complicated, which may enhance its capacity and to extract deeper characteristics from the input information. So, additional convolutional layer by including an extra convolutional layer with 128 output channels. Um, you have the depth, network depth. This may facilitate the model learning of deeper characteristics from the input data. And also the pooling layer adjustment is done to lower the amount of space after each layer of the convolutional. You implemented the maximum pooling with a 2 into 2 window and threads by lowering the computing complexity. And also the dropping layer adjustment has been done. A placeholder for the dropout frequency has been added to the dropout layer by temporarily fitting a position of cells during instructions. All these adjustments are made in to strengthen the model capacity to extract significance characteristics, deepen it, and boost its resilience while being trained. The CNN has been trained on the CIFR-10 dataset with the optimization algorithm ADAM and softmax cross entropy loss. So here is the result after the model has been improvised. So everything is done after testing the model. Ultimately, accuracy was found to be roughly around 72%. This indicates that of the photo in the CIFR-10 dataset, the model successfully categorized to 72% of them. The CNN model performance has been significantly improved as evidenced by the fact that this result is an important boost over the prior one. The earlier one, it was 65 and now it is 72, which was a drastic change. The system is now more adept to distinguish between different types of photos, which makes it more useful for practical image categorization tasks. So basically, according to the particular use cases and dataset, it's crucial to keep improving and enhancing the model in order to achieve even better outcomes. So what we can conclude is that in the convolutional neural network model, improvements contributes to its performance with its accuracy of 72%, 0.726. The model capacity to learn complex features has been improved, the danger of overfitting has been decreased, and the accuracy of the model is picture task classification has been increased. As a result of the extra convolutional layer, modified layers for pooling, and the implementation of dropouts, regularization, the CNN is strengthened by these changes and is better suited for real-world use cases, especially when used with the CIFR-10 dataset. Coming to the part 7. Part 7. The write an introduction section to introduce the project and everything. What all discussed everything. This in this project we use the TensorFlow and the Python to investigate convolutional neural network. The main objective is to use image datasets, particularly CIFR10, and carry out various activities to comprehend and enhance CNN performance. So coming to the part 7, so in this final project, what all we did is like I have developed a neural network model on the CIFR10 dataset. CIFR is like it's abbreviated as Canadian Institute for Advanced Research. Have developed for this dataset which contains images of various vehicles, birds and animals, etc. There are total 10 classes in the dataset. The data have 6,000 observations in total. Convolutional neural network is a neural network model which consists of one or more convolutional layers, which means convolutional operations of input with the kernel. The resultant dot product will be applied to RLU layer, which acts as an activation function. These two layers works in tandem. We can have any number of these combination layers in CNN model based on the parameters and data size layer we apply. The result to the pooling layer, which compresses the previous output dimensions by half. We can have pooling layer of the convolutional layer. Later, we flatten the result from pooling layer and apply it to a fully connected layer, which can be any number of layers based on hardware pattern parameters in the dataset. Finally, we have the output node, which are equal to the number of classes in the dataset. So coming to the project the description and what all activities that we made is um, I'll just give an overview of what we did exactly. Um, in the model, in the model one, as part of the preliminary model, I have developed the model with CNN containing two convolutional layer, which are also followed by max pooling layer. Then fully connected layer by applying a flattened version of pooled output. The model has produced an accuracy of 59 to 61% on testing data when run of for 5,000 steps. Since this model is simple and not hyper parameter tuned, I have made a few assumptions which help the model to improve its accuracy. So, um, my assumptions are normalizing the data between convolutional layer. My first assumption was to normalize result from the convolutional layer. I have added batches normalization in between the convolutional layer and max pooling layer. Batch normalization improves gradient flow in the network and reduces the need for regularization. So then I compared the model with the result of the MNIST CNN model. CNN model and this dataset have produced the result of accuracy greater than 94%. Then this model developed and on CIFR10 have produced only 60% with two convolution layers. So from the assumptions on May model 1 of CNN on CIFR10 dataset, I have the necessary improvements and Bill. Um, and Bell Model 2. There is an improvement in Model 2 after doing hyperparameter tuning. As explained during class sessions, batch normalization helps in improving gradient flow through the network, which has been worked out in many cases. So, what we can conclude from the results that I gained is like as we generalize the result from model 1 of CIFR 10 CNN, we can see the accuracy found in low since the model is very simple, not tuned, and not regularized. I've added batch normalization and dropouts layer in convolutional layer as I felt these were essential to have better results since we are performing predictive modeling on the 3D images. Adding these improvements, which help the model to improve test accuracy by 7%. So the final test accuracy I got for the improvised model is 72.6%, which is a significant improvement. The average accuracy for the last 10 samples of 10 test accuracy is 71.3%. So what I can conclude, finally, as we saw the basic model with lesser accuracy, which leads to drawing assumptions to improve the model capacity, thereby building the model 2 based on the improvements I understand from model 1 to model 2 have resulted in different results and accuracies when running through 5,000 steps of training data and testing the model at 50 distinguished ways. So in this model project using CNN on CIFR10, I have learned various hyper training parameters that drive the model and improve overall performance and predicting the result more accurately. It was major setback to strengthen the model in terms of accuracy. And also I'll list out the references that I've searched. So while uploading the video. Thank you.